If you can elevate muscle protein synthesis more frequently by training each body part more frequently, you can give your body more chances for growth throughout the week. High-frequency training will stimulate MPS on a more regular basis.
Take full advantage of more frequent spikes in muscle protein synthesis.
Muscle protein synthesis levels are constantly increased, so you build more muscle, letting those cells lay down new muscle fibers more consistently.
Keep you anabolic for the entire week.
Should you train a muscle with a higher frequency to consistently spike muscle protein synthesis and thereby keep yourself more anabolic? Using the current science, we'll assess this. First and foremost though, what is muscle protein synthesis and why is keeping it elevated important for muscle hypertrophy? Within your muscles, muscle protein synthesis and muscle protein breakdown are always ongoing. Muscle protein synthesis is the creation of new muscle proteins, while muscle protein breakdown is the degrading of muscle proteins. Bob the Builder and Thanos can help us understand this further. Imagine we have a wall. Bob the Builder is laying new bricks to the wall. Thanos, on the other hand, is destroying bricks. In this analogy, the wall is the muscle, and Bob the Builder is carrying out muscle protein synthesis. He is adding new bricks, while Thanos is carrying out muscle protein breakdown. He's destroying bricks. When Bob the Builder and Thanos are adding and removing bricks respectively at the same rate, the wall remains the same size. In correct terms, when muscle protein synthesis is equivalent to the amount of muscle protein breakdown, the muscle remains the same size. When Bob the Builder adds bricks faster than Thanos can destroy them, the wall increases in size. That is, when muscle protein synthesis exceeds the rate of muscle protein breakdown, muscle size increases. Finally, when Thanos destroys bricks faster than Bob the Builder can add bricks, the wall decreases in size. That is, when muscle protein breakdown exceeds the rate of muscle protein synthesis, muscle size decreases. This unfortunately occurs in aging, inactive individuals. A resistance training session evokes an increase in muscle protein synthesis and shifts the balance to muscle protein synthesis, exceeding muscle protein breakdown. But how much does muscle protein synthesis rise and last after a resistance training session? A review study by Damas and colleagues combined the current data investigating this, and established training experience seems to matter. For trained individuals, muscle protein synthesis peaks a few hours after a session, and by 10 hours the levels have rapidly fallen. Untrained individuals peak in muscle protein synthesis elevations close to 20 hours after a session, have a greater area under the curve compared to trained individuals, meaning greater muscle protein synthesis elevations overall, and they also still display fairly decent elevations 40 to 50 hours after the session. All this makes sense. Untrained individuals have greater muscle growth capacity than trained individuals. Resistance training is more novel for untrained folks and is going to disrupt their systems more. Nevertheless, based on this data, trained individuals might want to train a muscle every other day, while untrained individuals may want to train a muscle every third day. Doing so will ensure muscle protein synthesis is consistently elevated. What we've just done, examining the time course of muscle protein synthesis and deriving training frequency recommendations, is commonly what others do to support the idea of training a muscle more frequently, that is, training a muscle every other day for trained individuals or training every third day for untrained individuals. But there are a couple of problems with all of this. Firstly, the data formulating the time course of muscle protein synthesis elevations for trained and untrained individuals comes from studies looking at mixed muscle protein synthesis. Mixed muscle protein synthesis includes all the proteins within muscle fibers. Much of these proteins are not involved in muscle hypertrophy. We care about myofibrillar proteins, the contractile proteins within muscle fibers that produce muscle force. It's an increase in the number of contractile proteins that conventionally signifies hypertrophy. Returning to the Bob and Builder and Thanos analogy, it's most accurate to say when myofibrillar protein synthesis exceeds myofibrillar protein breakdown, we then get an increase in muscle size. Here's the thing, myofibrillar protein synthesis and mixed muscle protein synthesis do not correlate with each other. Demonstrating this, Bird and colleagues had subjects perform the leg extension for 4 sets of repetitions to failure, with either a 90% or 30% 1 rep max load. 24 hours after this, mixed muscle protein synthesis levels were unchanged, but myofibrillar protein synthesis levels were significantly elevated. Therefore, it makes no sense to use mixed muscle protein synthesis data to derive training frequency recommendations. This begs the question, what does the myofibrillar protein synthesis response look like after a resistance training session? The Damas and colleagues review study combined 2 studies and established this graph. The time course of myofibrillar protein synthesis elevations were similar between trained and untrained individuals. It peaked 5 hours after training, but the magnitude of elevation was lower in trained individuals. For both trained and untrained folks, myofibrillar protein synthesis was still elevated 16 hours after training. Unfortunately, neither of the 2 studies involved in this graph established when myofibrillar protein synthesis returned to baseline. Does any other data help us out? Before trying to answer this, there is yet another problem on our hands. Myofibrillar protein synthesis elevations are also impacted by the amount of muscle damage present. A different study by Damas and colleagues found across 10 weeks of resistance training, much of the myofibrillar protein synthesis elevations in the initial training sessions were likely directed mainly towards repairing muscle damage and not building muscle. However, as muscle damage levels gradually decrease as the training weeks go by, this is thanks to the body producing adaptations that make you resilient to muscle damage. The myofibrillar protein synthesis elevations after training was correlated with muscle hypertrophy. To rephrase all of this, when muscle damage levels are very high, as they would be when you first expose yourself to a novel training stimulus, much of the myofibrillar protein synthesis elevations are directed towards repairing damage, not building muscle. But when muscle damage levels are low or non-existent, then myofibrillar protein synthesis elevations correlate with muscle hypertrophy. What this means is that if we want to establish the time course of myofibrillar protein synthesis elevations that are directed towards building muscle, we're going to want to look at data that has ensured muscle damage is low or non-existent. 2 papers have technically done this. The aforementioned Damas and colleagues study found after a training session in the 10th week of training, a time point at which muscle damage was low, myofibrillar protein synthesis was still elevated 48 hours after the session. The researchers unfortunately did not take any more measures after 48 hours. Another study by Miller and colleagues had subjects perform one-legged kicking on a specialized equipment for 1 hour at 67% of their maximum workload. This protocol caused no signs of muscle damage, probably because I think it was purely concentric resisted training. Myofibrillar protein synthesis was still elevated 72 hours after the session. Unfortunately, no further measures were taken after 72 hours. Therefore, from this limited data, myofibrillar protein synthesis, when corrected for muscle damage, seems to last at least up to 48 to 72 hours after training. On the whole though, it's clear to see it's more or less impossible to derive training frequency recommendations from the current research examining myofibrillar protein synthesis. We've been assuming you'd want to wait until muscle protein synthesis has subsided to low levels until we train a muscle again and re-stimulate muscle protein synthesis elevations. But it's entirely possible there's nothing wrong with training a muscle again when its protein synthesis levels are elevated. There's no data, to my knowledge, demonstrating this is detrimental. but I should also note there are no data to my knowledge showing this is viable. Future research would need to examine this further. Throughout this video, we've also been ignoring the impact of the number of sets you perform for a muscle. The number of sets you perform for a muscle in a session likely impacts the magnitude of myofibrillar protein synthesis elevations, and this could potentially render the idea of frequently stimulating myofibrillar protein synthesis unimportant. For example, say you perform 9 weekly sets for your biceps. You could perform these sets across 3 days a week, with each session involving 3 sets. Presumably this creates a fairly consistent elevation of biceps muscle protein synthesis throughout the week. However, you could perform all 9 sets in a single session, creating one large biceps muscle protein synthesis spike. When comparing these two scenarios, perhaps the overall amount of muscle protein synthesis, technically called the area under the curve, is the same, meaning both methods produce similar hypertrophy. This is a possibility, but unfortunately there's limited data that can verify or falsify this. The idea training a muscle more frequently can produce more hypertrophy via more consistent muscle protein synthesis elevations is not truly supported by current data. This does not mean training more frequently provides no muscle growth benefit. It's possible future research indicates myofibrillar protein synthesis elevations, once adjusted for muscle damage, are overall greater when training a muscle more frequently. Using our previous example comparing performing 9 sets in one session to performing 3 sets across 3 days, maybe there could be a limit to the amount of muscle protein synthesis that can be stimulated per session. For example, 9 sets might be too much and past a certain threshold per session, meaning some of the sets you perform are essentially junk. Therefore, net weekly muscle protein synthesis will be greater by distributing this volume across more days per week. You avoid wasted sets. Regardless, the main point of this video is it's clear the current muscle protein synthesis data is insufficient to derive training frequency recommendations. Opposed to the muscle protein synthesis data, it's much better to explore the actual research comparing muscle growth after subjects train with different frequencies. We'll be diving into this literature next video to figure out if there's an optimal training frequency for muscle hypertrophy.